All right, so we're finally out of quadratics and into trigonometry. So it starts off, I think this one's pretty simple, but you do have to remember all the information we did yesterday about how triangles work and how lines and angles work. So it's a different sort of math, but you'll be using a lot of your skills in this guy. Should be short, but who knows? We've only got 8 slides, but talking to a blank screen seems to be a new hobby of mine, so I might just go off. We're investigating properties of similar triangles. So definitions. First two things we're going to talk about are congruent figures and similar figures. So congruent means the same. So congruent figures have the same size, the same shape, and the same angles. Why did I not capitalize those ones? So they don't have to be angled the same way or on top of each other. So this guy and this guy are congruent figures. This guy and this guy are congruent figures. And you could change them so that they're pointing in any direction, that they're all twirled around, as long as they have all the same sizes. So this length is the same as this length every time. All the same angles. You're a right angle, you're a right angle. You're so many degrees, you're so many degrees, you're the same, you're the same. As long as they are the same size, shape, same angles, they are congruent figures. Similar figures are same shape, same angles. Their length is in the same ratio, but they're different sizes. So length in the same ratio means that proportionately, if this was a 1 and this was a 1 and this was a 2, if this one's bigger, maybe this one's a 2, this one's a 2, and this one's a 4. So I've just multiplied all the angles by 2. So the same as all our other things, when we're multiplying by a number, we haven't changed the ratios at all. We've just changed the size. So those two, this one and those two, are similar figures. Whereas these two together, making a little happy face here, are congruent. So this is still a right angle. This angle is still equal to the little triangle's angle. They're the same angles. The only thing that's different is the length of the sides, but their ratio is still equal to each other. We've still got a 1, 1, 2 ratio. We've just multiplied it by 2. We've got a 2, 2, 4. And I haven't measured these. I'm just making up numbers. But they're just bigger in size. But the angles are still the same. The ratios are still the same. The angles are still the same. The shape is still the same. It's just a different size. So congruent figures are exactly the same, just kind of probably not facing each other. Or they can be in mirror to each other, like that. Not that I can draw straight, but if those were exactly the same, just mirrored, that could be a congruent figure, but not if there are different sizes. All right, already into example 1. Use angles to show that two triangles are similar. Identify a pair of similar triangles and explain why they are similar. Support each statement with a reason. All right, so we've got two triangles here. We've got one that goes from our man down to X and across there. We got one right there. So we need to name it. So we're going to put triangle NXP is in green. change colors. Now we've got another one coming from the tree. And this, they haven't done this willy-nilly. This is one way that we judge heights of something. I'm going to put a video up with this about finding the circular of the earth or the dimensions of the earth by looking at the shadows of mountains and things like that. Very interesting. And this is how they've judged the size of the pyramids, all before calculators and computers and any sort of models like that, by looking at the shadow from the sun. So if we look at the shadow from the sun, by knowing our own height and lining up our own shadow with the shadow of the tree, we can determine how high it is, because we know the ratio of these two similar triangles are going to be the same. But we're not doing that right now. But I'm just saying that is why that picture is set up the way it is. So our second triangle is EX. Now I've lost the number. What are you? A T. EXT. And so notice I'm doing it in the same order both ways with the X in the middle, because the X is the common factor. Let's see if they did it the same way I did it. Yeah, they put the X in the middle, but they put the T and the P first. But either way, so we try to usually would put the common denominator in the middle. It doesn't really matter, but we want to do it so that it's always going the same way. 1, 2, 3, 1, 2, 3. So you want to put that same pattern in it if you've got two that are looking the same like that. So we could draw those two out if we wanted to show that we've got two different triangles. P. They don't look similar when I draw them, but that's okay. We've got them labeled so that we understand. So explain why they are similar. So pause for a second and think about it. Why are these things similar? See what you come up with. Then we'll move on. So one of the ways we know that they are similar is because of, or the way we know this one's similar is because of the angles. We've got this symbol in the corner, and that's our universal mathematical symbol for a right angle, having a square in the corner of an angle. So we know these two are right angles. So we could write, so when we talk about an angle, so this is the symbol for triangle. And if you don't know, this is then the symbol for angle. So angle XPN, so again, now we're putting P in the middle because we're talking about the angle for P. Angle P, or XPN, and angle XTE are both right angles. Now we don't know what any of the other angles are, but we know that X is the same angle because it's the same triangle point. So either way, X, you can call it PXN or you can call it X or NXP, but put the X in the middle. Sometimes they just put angle X as well. I think this book, yeah, puts all three letters. Sometimes you can just call it angle X. So angle NXP and angle EXT are the same because they just literally are the same. Therefore, since all angles need to add to 180 degrees, and the other two angles are the same, then we know that these top two angles must be the same with each other. So we know those two are the same. I'll put a dash on them. So the top two angles need to be the same too. So let's call this angle XNP and angle XNP and angle XET. So the one we're talking about is always in the middle, are the same too. And what is our criteria for similar triangles? We have to have the same angles. We have to have the same ratios, which if we have the same angles, we must have the same ratios. So we just have to prove that we have the same angles. We can see that it's the same shape. They're both triangles. They are a different size, and the length has to be in ratio because all of the angles are the same. Otherwise, there wouldn't be the same angles. So that's kind of a rule we know too. So let's see what the textbook says. We've got these, both those are the same 90 degrees. The two x's are the same angle. The sum of the angle in any triangle is 180, therefore the two top ones are the same, and therefore all three are equal. So you can show that these two triangles are similar by identifying three pairs of equal angles. So therefore, triangle XPN and triangle XTE, all three pairs are equal, therefore they are similar. They are similar triangles. All right, sweet and simple. Example 2. Use sides to show that the two triangles are similar. So before we were looking at the angles, now we are looking at the sides. So we could do the same thing and prove that this is a right angle and that is a right. If those had right angle signs, we would know that those are right angles. We would know that, it's not a very nice right angle. We would know that these two opposite angles are the same by using our rules that we went through today, or yesterday for you, showing that when you've got two lines intersecting, that the opposite ones are the same, and then by process of elimination with the 180, we know the third ones are the same. But we're being asked to do this by showing the lengths. So we've got, let's erase that. We have similar lengths. So again, this one is a flipped one. So we need to think about it in its terms of its translation. So this angle and this angle being the same. So the one that is closest to it is the 15 and the 3. So those two are the same lengths in different ratios. So we've got 3 and 15 that are together. So that means that the top one and the bottom one are together if we have moved our ratios of, we've moved our triangles. So think about it as being twisted all the way around. And so which sides are which? This one, trigonometry has like a spatial element to it. So it's people that can see things moving in their brain will find it easier. So this line, CB equals 3 and CD equals 15. So these are our lines. And sometimes they ask you to put a line over top to prove it's a line. Doesn't look like our textbook's doing that. So looking at their ratio. So our next pairing is the top and the bottom. So again, think about it as this big triangle has been shrunk and twisted around on the C axis kind of thing and moved all the way around. So we're looking at kind of opposite things. So we have AB equaling 4 and DE equaling 20. Now, so our last two pairings, I'll do in black. We've got kind of our hypotenuse bits, 5 and 25. So the 5 is called line AC, and the other one is line CE or EC. Doesn't matter which direction you put the line in, as long as you've got both of those angles, or both of those one side to the other side. So AC is 5 and you are 25. Now, if we brought those down to their, so we kind of got 3 fractions on the go here. If we brought those down to their lowest fraction, we would divide this one by 3. We get 1/5. So kind of going down like that. And we divide this one by 4 to again get 1/5. And we divide this one by 5 and again get 1/5. So therefore, they are similar triangles in the ratio of 1 to 5. So the big one is 5 times the size of the small one. So 3 times 5 is 15, 4 times 5 is 20, 5 times 5 is 25. They're all in the ratio of 1 to 5. They're all the small one is the big one is a multiple of 5 of the small one. It's 5 times as big according to its lengths. So therefore, triangle EDC, and this is the symbol, we've got that not quite equals, but similar, if you want to use, they are similar triangles in the ratio of 1 to 5, or you can write, therefore, triangle EDC is similar to triangle ABC, is how you would say that. Since the triangles in example 2 are similar, their corresponding angles are equal. All right, so because, and again, I wrote in that this was a right angle, but I don't know that, so I can't really do that. I was just trying to show you that that angle equaled that other angle. But what we do know about these is because we've already proven that they're similar triangles, we now have proven that their angles are going to be equal. So angle ABC is going to equal angle ABC is going to equal angle CDE. We don't know what that is because they did not give us the right angle symbol, but we know that they're going to be equal. We know that angle ACB is going to equal angle DCE. We already know that because it's labeled C. It's the same one because we use our opposite angles rule for that one. We also know DEC. Oh, I should put them all on the same side. All the small ones together and all the big ones together. So which one am I missing? I'm missing A. So CAB is equal to angle DEC. And again, you can put that in any order. I probably should have gone clockwise every time to make it more noticeable, but as long as you get the one that's in the middle is the angle that you're talking about. Okay, so actually, there's the answers out of the textbook. And this is one where our Edwin, which you'll not be using because you're going into grade 11, but we're going to be starting to use an online textbook. And this is what they've asked, put as the key concepts in the online textbook. So this we talked about this morning. So we know that internal angles are going to all equal 180. Something else that I don't think was in your getting to know part is their complementary angles on the outsides, so X, Y, and Z, are going to equal 360 degrees. Also, we talked about this one in class. Because these two are complementary, and because, let's call this one C, it has to equal 180 degrees. So C and the one that's labeled AB have to equal 180 degrees because of it being in the line, and because all triangles equal 180 degrees, that C plus A plus B have to equal 180 degrees. So therefore, their complementary outside angle has to equal the addition of the other two angles on the inside. So a lot of these keys, like I said, doing trigonometry is like doing Sudoku and other word problems like that. They are very puzzle based. Your textbook, let's see if I can do this. Good. Probably shouldn't wear my pajamas while I'm doing this. This is what your textbook says. So congruent figures have the same size and shape. Similar figures have the same size but different shapes. Similar triangles have the following properties. Their corresponding angles are equal. So this is the other way the people write angles, is just using capital letters for angles, small letters for sides, and just putting angle A rather than angle BAC. So just be aware that they are written both ways. This is kind of the lazier way to do it. Sometimes it becomes a little more obvious if we had like another angle coming off here. We don't want to call them both T because T might mean this angle or it might mean this angle. So we want to say UTV or UTQ, whatever. So that's why we use three letters to identify them. Ratios of corresponding sides are equal. So if like we did the last problem, if you can divide down and have them be the same fraction, then they are in the same ratio. So those are the three things to work on there. Let's go back to PowerPoint. Oh, that worked out well. All right, last slide. Hello, last slide. Hello. I want to go to the last slide now. Oh, too far. Homework is page 333, starting on 3. So look back to the Getting Ready section for some information about some of these questions. So some of them are about the examples that we just saw, and some of them kind of go back to that get help, or what's called Get Ready section. So some of those rules. Again, I recommend making yourself a cheat sheet based on the Getting Ready information. So I said this last chapter. All of this stuff is going to come back in the Getting Ready time and time again, especially this guy, all the different types of angles. Slopes, I think you guys are good at because we've talked about slope a lot. And equivalent ratios. Again, we're already starting in on that. So make yourself a little cheat sheet, reminder of these basic things that you've talked about already. All right, this is the overall homework. I think since we're doing this on a Friday, I'm not going to do practice problems It's just going to be the homework for the weekend. All right, see you in class.